Hey, Koshan. This is our 414 dosage presentation on the toxicity of dish soap. So dish soap is like a common household ingredient that you could see in most households, and it's used for not just dishes, but for a variety of cleaning applications, right? So since it's so accessible, we really wanted to see how toxic it would be. So in this experiment, we chose to test the toxicity of dish soap using the germination of radish seeds.
So for this experiment, we tested the concentration of dish soap, 100%, 50%, 25, 12.5, and 6.5. And we see the result over a period of 11 days. So in table one is our initial measurement before we added any of the dish soap into our seeds. And in table two is after 3 days. And we can see there is some germination, a slight germination, so a little bit change with the control mostly, and the 6.25 dish soap. And table three, after 8 days, we measure again, and we can see there is major germination with the control and 6.5 dish soap. But overall, it's the germination for dish soap isn't that much, between 100% and 12.5%. So as you can see with these graphs, we can see the average seed length over the period of the days we measure. So day one is our initial one, and day two, three, and four is our measurements. And you can see the control is the most changed overall in these graphs, while the 6.25 being the second highest. And in the second graph over here, you can see the different of changes between day one and day two and day three and day four. In day three and day four, the concentration for 100%, 50%, 25%, and 12.5% didn't have any change between day two and day three, so that why they are blank. And yeah.
Okay, so for the results, the control group germinated with the exception of one seed. And then for the 6.25% concentration, there wasn't any growth within the seeds except for slight growth on one of the seeds. It was seen that in any concentration higher than 6.25%, that it would be considered toxic since there was no germination found in our experiment. Variation in our data can be explained by the different seed order that we reported in, because sometimes they got mixed up or we measured it the opposite sides. Different rulers, some of them were smaller, easier to read, harder to read, wooden. So it kind of changed, it could have affected our data collection. Different people measured it, so there's a chance that it could have been interpreted a little bit differently, but nothing major. And how they were measured, we tried to do it by the longest side of the seed if it didn't germinate, but sometimes you can't get the same angle every single time. Yeah.
So first we kind of set up like a parameter. So essentially, if the seed did sprout, then we would say that that would be non-toxic, and if the solution caused the seed not to sprout at all, we would say that that would be toxic. So from our data, we weren't able to conclude much. So we were able to conclude a lot and not a lot at the same time. So a lot meaning that we were able to narrow down the concentration of which dish soap is toxic down to 6.25%, because although one seed in the 6.25% group did germinate, using averages to have more accurate data, none of the other three did. So the average, in average, they did not germinate. So from that, we're able to tell that the the barrier where the concentration of dish soap and water begins to become toxic to germinating radish seeds is between 0%, which was our control, which germinated, and 6.25%. And this is our works cited. Thank you, Koshan.